Here we shall discuss about the electric field intensity at a point due to an infinite line charge. As already told you that the charge distributions are of different types in electrostatics, that is a point charge distributions, whatever the a charge which is in the form of a point in space, so that is known as a point charge. If the charges are distributed along a line, so that is known as the infinite, that is a line charge distributions, and that is the charge which is stored in that, it is the line charge density. Similarly, volume charge distributions, if the charges are distributed within a volume, that is known as the volume charge distributions. Similarly, if the charges are distributed on the surface of a plane, on the surface of, that is on a sheet, surface of a sheet or surface of a plane, then that is known as the surface charge distributions. Here we shall discuss about the electric field intensity at a point due to infinite line charge. That is, charges are distributed along the line, and that line, it is of infinite length. It is extending from minus infinity to up to the plus infinity. Minus infinity to up to the plus infinity, that is the charge distributions. Consider an infinite line charge placed along z-axis from minus infinity to plus infinity. From minus infinity to plus infinity, that is a line charge is placed along the z-axis from minus infinity to plus infinity. Okay. Point P is at a perpendicular distance r from the line charge. Point P is at a perpendicular distance r from the line charge. Point P is there, and it is at a distance of r from this line charge. Here, since that line charge is along z-axis, so that the point P at which the electric field intensity is to be determined is along the y-axis. R from the line charge lies along the y-axis. Point P is at a perpendicular distance r from the line charge, and it lies along the y-axis. Here, this one, it is the axis of the point at which you have to determine the electric field intensity. Along the length of the line charge, the differential element or an incremental element of line charge dl is considered at a distance of z from the origin, because immediately it's not possible to determine the electric field intensity at point P due to the entire this line charge distribution, which is extending from minus infinity to plus infinity. That's why here, first of all, you have to consider the along the length of that line charge some incremental length or some differential length, so that you have to determine the electric field intensity at point P first due to this incremental length, which is having some line charges, that is it is having some line charge and charge is stored in that the differential length or the incremental length. Here first you have to determine the electric field intensity at point P due to this incremental length. Since that is dl is considered at a distance of z from the origin, a differential or an incremental element of line charge dl is considered at a distance of z from the origin. dl is equal to dz since is distributed along the z axis. Since it is distributed along z axis from minus infinity plus infinity, so that the value of that differential length is equal to dz. The charge of differential length is the charge stored in that differential length is equal differential length of the element is equal to dq is equal to rho l dl. dq is the differential charge or the incremental charge which is stored in the incremental length of the line charge, and here it is the line charge density of that line charge distributions, that is equal to rho l. Now dq, that is the incremental charge which is stored in that dq is equal to rho l dz. The coordinates of incremental length dl are 0, 0, z, and coordinates of point P are 0, r, 0. Because the coordinates of dl, that is the incremental length, are 0, 0, z, that is along the z axis. Since the coordinates of point P, since P it is lies along the y axis, so that 0, r, 0, these are the coordinates of the incremental length and the coordinates of point P at which electric field intensity is to be determined. Because at point P x is equal to 0 and z is also equal to 0, because the length, that line charge is along z axis, and x coordinate of that point P is also equal to 0. Point P it is lies along y axis, so that the coordinates of point P are 0, r, 0. Here the coordinates of that differential length is 0, 0, z. So the distance from dl to point P, that is incremental length, to point P is, it is the capital R, that is a distance of these 2 points, that is equal to r. The unit vector in that direction dl to point P is r is equal to P minus dl. Here that is a unit vector along that distance, along the direction of that distance vector, that is r, is equal to P minus dl. R is equal to, the coordinates of P are 0, r, 0, coordinates of dl is 0, 0, z, so that the that distance vector r between these 2 points is r ay minus z az, because the point P is having the coordinate value 0, r, 0, point dl it is having 0, 0, z. From that will be determine this. Here the unit vector in that direction from the dl to point P is r upon modulus of r is equal to r ay minus z az upon square root of r square plus z square. The differential electric field dE at point P due to dq is the differential electric field dE at point P due to that differential charge is dE is equal to dq upon 4 pi epsilon naught r square AR. Differential electric field dE at point P due to differential charge is dE is equal to dq upon 4 pi epsilon r square into AR. So that dE is equal to dq upon 4 pi epsilon into bracket of square root of r square plus z square whole square r ay minus z az upon square root of r square plus z square. So that the differential electric field is equal to rho dq is equal to rho l dz upon 4 pi epsilon naught into bracket of r square plus z square whole raised to 3 by 2 into bracket of r ay minus z az. Since line charge is distributed, along the z axis from minus infinity to plus infinity, so that the z component of E gets cancelled. The z component of electric field along the z axis, it is cancelled because the line charge is distributed from minus infinity to plus infinity along the z axis, so that the electric field intensity along the positive z directions and along the negative z directions, so both are equal. Because here in this equation of the differential electric field intensity, that is here you have included other terms. Since that line charge is distributed from along z axis from minus infinity to plus infinity, the z component of E gets cancelled, because electric field intensity along the positive z directions and the electric field intensity along the negative z directions, if we add both the electric field intensities, then there will not be any presence of that the z component of the electric field intensities. These are equal in magnitude but opposite in directions, so that there will not be any presence of the electric field intensity along the z directions. For here, so this equation, it can be again, it is simplified as the differential electric field intensity at point P due to that differential element or the incremental element is rho l dz upon 4 pi epsilon naught into bracket of r square plus z square whole raised to 3 by 2 into r ay, and here in this equation you have eliminated the z component, because the electric field intensity is cancelled along the z directions. Now differential electric field intensity dE, it can be again, it can be written as rho l. This one, it is the line charge density of that line charge, and r, it is the distance of that line charge from the distance of the point at which the field is to be determined from the line charge dz and ay upon 4 pi epsilon naught bracket of r square plus z square whole raised to 3 by 2. Now the total electric field at point P due to the entire line charge, the total electric field at point P due to entire line charge is line charge extending from minus infinity to plus infinity is E is equal to, because whatever that equation which we have got, this equation which we have got, it is only for the differential element, that is the incremental element which is considered along the infinite line charge, that is a incremental electric fields. But here you have to determine the total electric field intensity due to entire line charge extending from minus infinity to plus infinity. Here rho L r dz ay upon 4 pi epsilon naught into bracket of r square plus z square whole raised to 3 by 2. Now tan theta is equal to, because here know that this is the how we will be getting the tan theta. Here it is angle theta. The opposite, the tan theta is equal to z by r. Tan theta is equal to the tan theta is equal to the z by r. From this triangle, it is a right-handed triangle, right angle triangle, so that the angle tan theta is equal tan theta is equal to the z by r, because that is a right angle triangle. From that we will be writing this z is equal to r tan theta, and the dz it can be written as the r sec square theta d theta. Dz, the differentiation of that z is equal to r sec square theta d theta. Now the electric field intensity due to the infinite line charge is from minus infinity to plus infinity, rho L into r, this one. Dz is equal to the r sec square theta d theta ay upon 4 pi epsilon naught into bracket of r square plus r square tan square theta whole raised to 3 by 2. Because here the z is equal to r tan theta it is, so from that shall be writing r square plus r square tan square theta whole raised to 3. Here minus integral, that is the here integral minus infinity plus infinity rho L, that is line charge, r square sec square theta d theta ay upon 4 pi epsilon naught bracket of, here if we take this r square as common, so that it is equal to r raised to 3 bracket of 1 plus tan square theta whole raised to 3. Integral minus infinity to plus infinity rho L r square sec square theta d theta ay upon 4 pi epsilon naught into bracket of r cube sec cube theta. So infinity plus infinity rho L, here if we simplify this equation it will become upon 4 pi epsilon naught d theta upon r sec theta. So that the electric field intensity is rho L upon 4 pi epsilon naught r. If we again simplify this equation, into minus infinity plus infinity 1 upon sec theta d theta ay. Here since that line charge is extending from minus infinity to plus infinity, r, that is the distance of that point p from the line charge, it is r is constant, and z is equal to r tan theta, so that theta is equal to tan inverse of minus infinity is equal to theta is equal to minus pi by 2, z is equal to plus infinity, for that theta is equal to tan inverse of plus infinity, it is equal to pi by 2. From that one, the electric field intensity at a point due to that infinite line charge is minus pi by 2 to plus pi by 2 rho L upon 4 pi epsilon naught r into 1 upon sec theta d theta ay. Rho L upon 4 pi epsilon naught r, that is the line charge density, this is the distance of that point from the line charge. Now integrations of minus pi by 2 to plus pi by 2 cos theta d theta ay. Rho L upon 4 pi epsilon naught r, the integration of cos is sin theta, so that first rho L upon 4 sin pi by 2 minus sin pi by 2 is equal to the 1 minus bracket of 1. So here rho L upon 2 pi epsilon naught r ay, because the direction of that electric field intensity is along the y directions, and rho L, it is the magnitude of the line charge density of the line charge. Rho L is the magnitude of the line charge density of the line charge, and r, it is the distance of the that point from the line charge. So that here in that way you shall determine the line electric field intensity at a point due to the infinite line charge. Here one thing that is to be noted is that here it is depends the electric field intensity, it depends upon the magnitude of the line charge density, and it depends upon the medium in which that line charge density is placed. So that, and r, it is the distance of the point. And another point that is to be noted is that it also depends upon the unit vector in their directions. Since the point P, it is along the y directions or along the y axis, so that the electric field intensity is also along the y axis or along the y directions, so that this ay, it is a unit vector in the direction of the electric field intensity. Now ay, it is the unit vector along the y axis, r, it is the distance of point P from the line charge. In general shall write rho L upon 2 pi epsilon naught r into ar. That is the equation for the electric field intensity at a point due to an infinite line charge. Now a uniform line charge of infinite in extent with line charge density is equal to 20 nanocoulomb per meter lies along the z-axis. Find the electric field intensity at 6, 8, 3 meters. Here the infinite line charge is extending from minus infinity to plus infinity, and the magnitude of that line charge is 20 nanocoulomb per meters x, y and z, and this is the point P 6, 8, 3. That is the point P at which you have to determine the electric field intensity. Since the line charge lies along the z axis, E along z directions is 0, because when it is the line along the z axis and it is infinite in extent from minus infinity to plus infinity, then the magnitudes of the electric field intensities along the positive z directions and along the negative z directions are equal and opposite. The magnitude of the electric field intensities along the positive z directions and along the negative z directions are equal and opposite, so that if we add the electric field intensities both due to positive z and directions and negative z directions, it is equal to 0, so that the electric field intensity along z directions is 0. Now so the electric field intensity due to infinite line charge is rho L upon 2 pi epsilon naught r into ar. Here z component is not considered. To determine the distance of that point P from the line charge, here you shall not consider the z component, because line charge it is lies along the z axis, so that r is equal to 6ax plus 8ay. The unit vector in that directions is equal to r upon modulus of r is equal to 6ax plus 8ay upon square root of 6 square plus 8 square. The unit vector in that directions is equal to 6ax plus 8ay. 6ax plus 8ay upon the 10 is equal to 0.6ax plus 0.8ay. 0.6ax plus the 0.8ay. So the electric field intensity E at point P due to the line charge along z axis can be written as rho L 20 into 10 raised to minus 9 upon 2 pi epsilon naught r. 2.854 and 10 raised to minus 12 into 10, 0.6ax plus 0.8ay. The electric field intensity E is equal to 35.9 into bracket of 0.6ax plus 0.8ay is equal to 21.57 AX plus 28.76 A1. That is the magnitude of the electric field intensity at point P due to a infinite line charge distributed along the z-axis. Here, one thing that is to be noted in the equation for the electric field intensity is that it is present only along the x directions and only along the y directions, so that there will not be any presence of the electric field intensity along the z directions. Find electric field at point P 1, 5, 2 meter in free space if a uniform sheet of charge with surface charge density is equal to 25 nanocoulomb per meter square is located over the plane z is equal to -1. Electric field intensity at point P 1, 5, 2 meter in free space if a uniform sheet of charge with surface charge density is equal to 25 nanocoulomb per meter square is located over the plane z is equal to -1. Here this is x directions, here it is y directions, and here it is the z directions. Since all the coordinate values of that point P are 1, 5, 2, that is point P. Here this one it is z is equal to -1 plane. It is the positive x directions, here it is positive y directions, and here it is positive z directions, and this point it is equal to z is equal to -1. It is a plane. On that plane surface the charge is distributed. On a plane which is placed at z is equal to -1, the charge is distributed on the surface of that plane. Now, to determine the electric field intensities due to the charges distributed on the surface of the plane at a point P which is having the coordinate values 1, 5, 2. Since point at which electric field is to be determined, this is the plane that is placed at z is equal to -1, and charges are distributed on the surface of that plane, and here you have to determine the electric field at that point P due to the charges which are distributed on the surface of this planes. Since the point at which E is to be determined is above the surface on which charge is distributed, the direction of electric field is along positive z directions. The direction of electric field E is along positive z directions. So here one thing that is to be noted is that P is at this point, surface is at this point, so that the direction of the electric field intensity it is along positive z directions. It is not along the negative z directions. So that here the electric field that is equal to rho s upon 2 epsilon naught into Hz. Just you have to think about whether it is in the positive z directions or along the negative z directions. The electric field intensity here in the problems associated with the surface charge distributions, it only depends upon it is totally independent of the distance, because the electric field intensity at a point due to the surface charge distribution is totally independent of the distance of that point P from the surface. Here it is totally it just depends upon the medium at which that charges are distributed on the surface, and it just depends upon the magnitude of the surface charge density, and it is totally independent of the point P from the surface. It is totally independent of the point P from the surface charge distributions. It just depends upon whether in the directions in which that electric field intensity, whether it is in the negative z directions or it is along the positive directions from the that charge distributions. Now since that point P, it is above the plane and plane on which the charges are distributed, which is placed at z is equal to -1, because here z it is 2 and here it is z is equal to -1, so that the direction of the electric field positive z direction, because here it is z is equal to 2, but here it is the z is equal to -1. This is the plane, it is in the positive z directions. The direction of the electric field intensity is along the positive directions. The surface charge, it is 25 nanocoulombs, and the epsilon naught, it is 8.54 into 10 raised to -12 into plus a z. Here this one, the other you have to indicate, it is positive z directions. From that the electric field intensity at a point P is equal to 1.41 into 10 raised to 3 Az volts per meters. So in that way shall determine the electric field intensities at any point due to the surface charge distributions. That is, charges are distributed on the surface of a plane. Okay. These are the questions.